Hello and welcome back. So another question I might ask you is to find an orthogonal value p to remove the cross product in the equation 5x squared plus 4x plus 5y squared equal to 42. So the cross product term that you want to remove is actually this 4xy. Okay, so and one of the ways one of the application of eigenvalue and eigenvector is using it to remove the cross product in equations like this. So if you are asked to find an orthogonal value p, okay, to do that, and is to remove the cross product in any equation like this, all you have to do is first to create a new matrix. So you can label that as matrix A. Now you're going to check your equation. The number of unknowns that you're going to see there is the number of sides of your square matrix. So we have x here and we have y here. So we have two unknowns here. So your square matrix is going to be what? 2 by 2 now, because we have two unknowns. And if you want to form it, it is going to be x, x, y, y. Okay, then you now multiply from left to right by x and y. So if you multiply this by x, we have x squared, and this one by y, you have xy. Multiply this by x, you have x, and multiply this by y, you have y squared. So if your unknowns, maybe you are still having z in this equation, so it's going to be 3 unknowns like that, and that's going to be 3 by 3 matrix. So your 3 by 3 matrix, you have x, 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 y, 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 z, z, z. So you start multiplying by x, y, and z. So we have x squared, xy, xz, yx, y squared, yz, zx, zy, z squared. So this is going to be your 3 by 3 matrix if you are given 3 unknowns. Alright. So, but we are given 2 unknowns in this problem. So that means we are going to form 2 by 2 matrix, the one we have here. So the next thing now is to find the coefficient of each of them in the equation given to you. So the coefficient of x squared here is 5. That of y squared is 5 as well. That of xy is 4. But we're having 2 xy here. So we're going to split it for them. So the coefficient of xy here, you divide it by 2 because you're having 2 xy here. So that's going to be each of the value of xy in this matrix. So dividing 4 by 2, you have 2 here and you have 2 here as well. So this is your matrix A. Now we are going to find the eigenvalue and eigenvector of this matrix. So to find the eigenvalue of this matrix, we're going to use the shortcut. We use the R time lambda squared minus trace lambda plus the determinant of that matrix. So the determinant of this matrix is going to be 5 times 5 minus 2 times 2. That is 25 minus 4, which is 21. And the trace would be 5 plus 5. That is going to be 10. Okay, so your characteristic polynomial will be lambda squared minus trace is 10, lambda plus the determinant, which is 21. Adding equal to 0, that gives characteristic equation. We're aiming to find the eigenvalue. So two numbers you multiply to get 21, you add and you get 10. And you get negative 10. So that's going to be lambda squared minus 7 lambda and minus 3 lambda plus 21 equals 0. So we have lambda minus 7 minus 3 lambda minus 7 equal 0. So lambda minus 7 lambda minus 3 equal 0. So lambda can either be 7 or lambda equal 3. So these are the two values of your eigenvalues. So lambda equal 7 or lambda equal 3. Now we're going to find the eigenvector. So to find the eigenvector, you see when lambda equals 7, now you say the equation, from a minus lambda I v equals 0, we can have a, okay, which is this, minus lambda I. So in short, it's going to be 5 minus lambda 2, 5 minus lambda times the eigenvector v1, v2 equal 0. So you get your eigenvectors from here. So to get your eigenvector, you're going to put lambda equal 7. So when lambda is equal to 7, we have 5 minus 7 to 5 minus 7. v1, v2 equal 0. So minus 2 to 2 minus 2. v1, v2 equal 0. From here, when you solve it, you have minus 2v1 plus 2v2 equals 0. 2v1 minus 2v2 equal 0. So these two equations are the same. So from equation 1, 2v1 will be equal to 2v2. And we have v1 equal v2. So in that case, your v1, v2, the vector is going to be 1, 1 when they take the coefficient of each other. So that's not the end anyway. But before we continue, let us find the eigenvector for the second eigenvalue. So for the second eigenvalue, that was gotten to be 3. So just going to continue from here. So we're going to put 3 here when lambda equal 3. Don't forget, we got 2 lambdas, 7 and 3. So for 7, the eigenvector is 1 on 1. And for 3, we're going to have 5 minus 3, 2, 2, 5 minus 3. Then we have v1, v2 equal 0, 0. So 2, 2, 2, 2. So it's very obvious that we're going to have two equations that are exactly the same. So for that case, we have 2v1 plus 2v2 equal 0. The same for the second equation as well. So I don't need to bother myself. So we have 2v1 equal minus 2v2. Okay, minus 2v2. And we have v1 equal minus v2. So we have v1, v2 equal, so v1 will take the coefficient of v2, that's minus 1, and v2 will take the coefficient of v1, and that is 1. Now, that's not the end. There's something we call normalization. We're going to normalize these vectors that we got here. So before we do that, let me create some spaces here, some space. So the first eigenvector gotten was v1, v2 equal 1, 1, and the second one was v1, v2 equal minus 1, 1. Yes, that was all good. So now we need to normalize this eigenvector. Okay, so how do we normalize? Generally, if you have a vector a, b, okay, and you want to normalize this vector, so the normalization will be a, the first term, over the square root of the sum of the square of all the elements. So, and we have the second term as well, the same thing like that. So the same thing if you have like 3 terms, so like a, b, c, so you just do for each of them, and that will be the square root of the square of all of them. So that's how to normalize. You do for b, you do for c as well. Now I believe by now you'll be able to normalize this vector that we got. So let's see how to normalize these vectors. Now to normalize the first vector we have 1 over square root of the first one, 1 square, plus the second one, 1 square. we have also 1 over square root of 1 square plus 1 square, because we are going to do for each of those elements. So the same thing here, we have minus 1 over square root of minus 1 square plus 1 square, and 1 over square root of minus 1 square plus 1 square. So this is going to give you 1 over square root of 1 square plus 1 square. 1 square is 1, 1 square is 1, 1 plus 1 is 2. The same thing here. But here we are going to have minus 1 over square root of minus 1 square is 1 and 1 square is 1. So that the sum is 2 now. The same thing here as well. Alright, so now we're going to form a new matrix. Okay, we're going to form a new matrix. And that matrix is going to be P. Okay, we have P equal. Now all those normalized vector that we got, so we're going to put them there one column wise, the same we did the last time. We're going to put them there column wise. So here we have 1 over square root of 2 followed by this 1 over square root of 2. Then this one, so we'll put it like that. But instead of you to put minus 1 and 1, it is going to be the normalized value that you put. So just as we are doing, so that was going to be P. Now after we've gotten this P, you're going to find P transpose. I know transpose is not really hard. Just change the rows to column or the columns to local to row. So if I change the rows to column, so these are the columns actually. So if I change the first column to row, that's going to be this. Now slant like this. We have 1 over square root of 2, 1 over square root of 2 as well. The second row, the second column, we change to second row in order. So that's minus 1 over square root of 2 and 1 over square root of 2. So that's going to be your transpose. Okay. So after you normalize and you got your P transpose, the next thing is now to find the matrix of interest, which is, you can label it any letter of your choice. So I choose to use B, and that's going to be P transpose times the A given to us and the P. So the P transpose is 1 over square root of 2 minus 1 over square root of 2, 1 over square root of 2, 1 over square root of 2, then times A. A is 5, 2, 2, 5. 5, 2, 2, 5. Then times P. So the P is 1 over square root of 2 minus 1 over square root of 2, 1 over square root of 2, 1 over square root of 2. So now we multiply in order. So we start from the left to the right. So the first row multiply by the first column. So we have 5 over square root of 2 plus 2 over square root of 2 as the first row, first column element. First row times the second column, we have the first row, second column element. So we use this one as well to multiply the two columns. So we have minus 2 over square root of 2 plus minus 1 over root 2 times 5, that's minus 5 over root 2. Then plus 2 over root 2 minus 2 over root 2 plus 5 over root 2. Just multiply them. So this times this, we have this, and this times this, we have this. So that's it. Then times 1 over root 2 minus 1 over root 2, 1 over root 2, 1 over root 2. So B will be equal to, this is 7 over root 2. So minus 5 plus 2, that's minus 3 over root 2. 7 over root 2, 3 over root 2 times 1 over root 2 minus 1 over root 2, 1 over root 2, 1 over root 2. So we have b equal this times this, so 7 over root 2 times 1 over root 2, that's 7 over 2 plus 7 over 2. Also, we have this times this, so that's going to give us minus 7 over 2 plus 7 over 2. This times this row times this, so we have minus 3 over 2, then plus 3 over 2, and this times this, we have 3 over 2 plus 3 over 2. Good. Now we have b equal 7 over 2 plus 7 over 2, that's 7. Then this is going to give us 0, 0, and we have 3 as well. So this is the matrix of interest. This is the matrix we want to get. And from here, we are going to compare to the first matrix that we have. So that was x squared xy, okay, x squared xy, xy, y squared. So from this matrix that we got, we can see that the coefficient of x squared now is 7. So we have 7x squared, then plus, so all the xy terms are now cancelled. Can you see they are now having coefficient of 0? At least they are not even part of the equation at all. So we have plus y squared equal to 42. What we have here the other time, 42. So now this is our new equation now. So as you can see, we have removed the cross product term, which was xy. So as you can see that in this new equation there was something like xy again. So that is how to remove it. So the first step, let me reiterate, is to create a square matrix depending on the number of unknown given to you. If it is 2 unknown, that's going to be 2 by 2, 3 unknown, 3 by 3. Then after that, you put the coefficient of all those x, y, x squared, and the likes. Then after you've gotten the matrix, which is the coefficient of all those terms, the next thing is to find the eigenvalue and eigenvector of that matrix. After you've gotten the eigenvector, you have to normalize. If you normalize, you put them in a new matrix P, column by column. Then after that, you still have to find the transpose of that matrix. So after you've gotten the transpose, then you find a new matrix, which is the product of the transpose times the A you got, then times the P. And after you've gotten that, you notice that your diagonal element, the second diagonal element, will be 0. So it means that all the xy term will have been cancelled. So we have just x squared and y squared, and that's going to be your answer. And if you like, you can put it in the form of x squared over 42 and divide by 42 all through. So this is supposed to be 3, okay, because the coefficient of y squared now is 3. Okay, so the coefficient of y squared here is 3. So we have 3 over 42, y squared equal 42 over 42. 7 over 42 should give you like 6. So 7 here 1, 7 here should give you 6. So we have x squared over 6 plus 3 in 42. That should give you, ain't sure, but you should have 7 in 42. If you should have 6 here, then definitely times 2, 14. Alright, you should have 14 here equal 1. So that is another way of leaving your equation. So that's all on our question. Thanks for watching. So that's all. If you are given any question, just follow the step the same way to get your results.